in the answer that's given to you your whole life, and nobody else has ever told you alternative reasons for that. So you've held that to be, the actual truth. The 9 meters per second, 8 seconds squared, or whatever it is. You hold that number to be the calculation of something going down. But you said that it's the best current one you've known, but it's the only one you've been given. It's the only one you've ever been given. So there is alternate explanations for the things that you see. And like I said earlier, I don't want to repeat myself. What I would call relative density is a very good argument for not just things going down in isolated situations, such as dropping a brick, but it also is in tune and explains things like, helium balloons going up. You've been told that the air atmosphere has been pulled down and it creates like a pressure downwards, and that's when the helium atoms get into the molecules get into the atmosphere. Because of the downward force of the rest of the molecules, it pushes them up and it escapes through. But it's all the same thing. At equilibrium, it's all the same thing, but we don't isolate things falling down and isolate things going up with buoyancy. Do you know what I mean? This is something that you've been brainwashed to believe.
Objection.
What's your objection?
He's still repeating the same argument, and it's becoming we're just wasting. We're taking up a lot of time. Where he keeps saying that I'm not going to be able to understand this, and I'm not going to be able to understand this.
1 second. I think he's changed the way what he's saying to you now. So I'm gonna take that as an invalid objection, because he is telling you about what gravity is instead of your state of mind of what you're thinking about. So it's not circular anymore. It's actually getting to a discussion about what gravity is in the way you perceive it. So it's a different topic. So I am at this point going to take one of your objections away. You now have 2 objections left. Reasons, go ahead and continue.
Yeah. So, things going down and things going up are all the same thing. It's part of that equilibrium thing. Everything is to its, relative to its density that it's in, the medium it's in. You remove the medium, that will affect it. You change the item, put it in a different situation, and it will behave differently, because everything is all seeking its own individual equilibrium. That's what's actually truly happening now. So yeah, that's what I've got to say to you.
Okay, so here's my response. Do objects slow down when they are encountering a medium? In other words, let me be more clear. If I throw a ball in a thicker medium than 1 atmosphere, will the ball go further than it would if it were in 1 atmosphere, or will it go further if it was in 1 atmosphere than it would in the thicker medium?
Obviously, the thicker medium would cause more resistance. But like I said, it's all relative to the density that it's in. You put a force behind a ball and you throw it through thicker air. Yes, you'll get less results if it's the same power in 2 different atmospheres.
Okay. If I drop a ball in a medium that is thicker than otherwise, will it fall faster through the thicker medium or slower through the thicker medium?
Obviously, it'll go. Obviously, the more dense the medium, then the slower it will go through the medium.
Okay. So now, is the medium thicker at lower altitudes than higher altitudes?
Well, there's more medium on top of medium, so that'd create a pressure gradient. And that's where you're going with that,
Nope, I just need my questions answered.
Okay, yes, it would increase you the deeper you go.
So if the medium is thicker, and you say that things go slower in the thicker medium than they do in the thinner medium, and things are falling faster as they're headed towards a thicker medium. Is that right?
Faster in thicker medium. I didn't say that.
And let's try again. You agree that the medium is thicker as you go down. You agree to that. You also agree that things go slower if they go through a thicker medium, right?
Yeah, no, say it again. I didn't say they get thicker.
Okay, let me ask the question separately. It's fine. No, it's fine. We'll just take it from the top. Does an object go faster through a thicker medium or a thinner medium?
It goes faster through a thinner medium, obviously.
Okay, it goes faster through the thinner medium, and it goes slower through the thicker medium.
Yeah.
Is the medium thicker as you go down, or is it thinner as you go down in altitude?
It's thicker. Not actually thicker, but it's just there's more medium to go through. So when you've got medium on top of medium, for example, a deep ocean, it's the same. It's the same sort of density, but when you have more medium on top of medium, then that will increase. and there'll be more resistance as you go further down.
Yeah, that doesn't. I'm going to object to that. That was not an answer to my question.
Okay, so there's an objection. What's your objection, Flatten?
I asked him, is the medium thicker as you decrease
Oh, yeah,
altitude?
it should be no.
And he did not.
He's right.
So,
he's right.
So
right.
the medium is thicker as let's verify. The medium is thicker as you go lower in altitude.
No, the medium is not thicker.
So if I'm at a high point like Mount Everest, the top of Mount Everest, are you trying to tell me that the density of the air at the top of Mount Everest is the same density as the density of air at sea level?
No, I'm not saying that. There's obviously a gradient.
Okay, so there's a gradient. So again, I ask you, does the medium increase in thickness and density as you go lower in altitude? Yes or no?
What, say again.
Does the medium increase in density? The air medium, the gaseous medium, increase in density as you go lower in altitude?
Well, there's less of the medium in the air because it scatters, right? So
Objection.
you're talking about what are you asking me?
There's an objection.
It is
What's your objection?
It's a yes or no question. It's does the
right,
medium
so, no,
increase?
I don't agree with that.
Hang on, Flatten. Hang on. So reasons he's asking you a yes or no question to his question.
It's not clear because he's talking about different things. Though.
All right, so Flatten, can you make it clear the yes or no question that you have asked him?
I'll try my best. As you decrease in altitude in the gaseous atmosphere that we live in on this Earth, okay? So I said I've made it very clear where we are. As you decrease in altitude from a high elevation to sea level, does the atmosphere around you increase as your altitude decreases?
Yes, that in reality, it's more dense as you go lower to the floor. The air is more dense, but the actual molecules itself don't increase or decrease. They stay the same, but there's just more of them the lower you go to sea level.
Objection.
Objection on the table. Hang on, reasons. What's your objection, Flatten?
He's giving an answer and then he's giving a contradiction to his own answer.
Not really, because you're not answering the question clearly. You're saying, does the air get... Well, sorry.
Yep. So at this point, I still haven't heard anything that he's saying incorrect. He's basically he's stating his statement was that the molecules stay the same. They don't get thicker. There's just more of them. That's what he's saying.
That wasn't my question.
Well, because you're asking me about altitudes, and obviously at sea level, there's more of them gas molecules that are together, but that don't mean they get thicker.
I didn't say thicker.
You said it gets more dense.
I said does the density increase at sea level compared to at a higher altitude?
The density of a gas molecule or the density of the collection
not of
gas
a
molecules?
Gas molecule. The density of density is not of a molecule. A density is of a particular volume. Any particular volume, the same volume measured at the top of a high mountain versus that same volume measured at the
but
sea
it's not
level
the same amount of volume. It's a gradient. What? So you have the same molecules in the air as you do at the bottom, but you have more molecules at the bottom. So there's more of them to get through. So it's denser.
Okay, you're going to have to open up your mind to understand a little bit more clearly. I've
said it very clearly. There's more of them at the sea level. There's more molecules. The same molecule at the top of the air. There's just less of them. There was a gradient.
That's not what I asked you. That's not what I asked you.
Is what you're asking me? That is literally
I'm
word for
going to
word
say, no, it's not. I said to you again, the same volume, if you measure the same volume at sea level as you do at the top of a high mountain, will the amount of...
Right, I object. I'm using my objection now. This guy is talking
nonsense. Yeah, go ahead, reasons.
You don't have the same volume at the top of a mountain as the same volume as you have at sea level. There is a clearly difference between the volume of gas molecules in the atmosphere at mountain level as opposed to the ground level. So his question's invalid.
I'm going to object to your objection.
Go ahead. Go ahead, Flatten.
When I speak of a volume, we're talking about cubic meter. Okay, a cubic meter is a cubic meter, and when I state that we are comparing a cubic meter to a cubic meter, it will be the same because that's the constant in this conversation. So I say to you, I am saying that we are comparing a cubic meter at sea level with a cubic meter at the top of Mount Everest.
And you said they're both the same volume? But
That's what I'm trying to tell you. If they are the same volume,
I've already explained this to you. There's more of them gas molecules at sea level than there is in the air. This is ridiculous.
so then the answer would have been a resounding yes. It is more dense at sea level than it is at the top of a mountain, and that would have been the end of it.
All right, let's move on then.
All right, so yes, so now since objects objects move slower through a more dense medium, and you're saying that the cause of things falling is due to relative density, I am not able to understand how objects can fall towards a more dense medium, since the medium, as you have agreed, is more dense. They should go upward towards the less dense medium, since we're talking about.
What's he on about? Objection. He said something should go upwards. He ain't even stated what items falling through the medium. He hasn't stated any of the.
Yeah, 1 second, guys. When you say objection, you have to give me a chance to ask you guys what the objection is for. That way you can give your whatever objection you're stating. Go ahead, reasons. State your objection.
He hasn't stated what item is dropping for the medium. He hasn't stated the density of the item dropping for the medium. He's just basically setting up a very invalid argument with no premises of what example he's trying to. It's not explaining himself properly, basically.
Point of clarification.
All right. 1 second, Flatten. All right, so now there's a point of clarification here. Reasons has asked if there's any way that you can explain what you're talking about that's going through the medium, so that we can make a distinction as to what's happening here. Because all we're doing right now is talking about things, but we're not getting to the heart of what we're talking about. So let's bring a point of clarity here and maybe use an example so that we can look at what's going on. So,
okay,
can you...
Sure.
Go ahead.
Let's see here. A baseball. A standard American baseball. And if you're in England, let's say a standard English cricket ball. So, have I provided enough clarity, or do you need more?
Reasons, are you with us still?
Oh, sorry. Yeah, he didn't state it. Yeah, but the problem, I was muted. I didn't realize I was muted. Listen, you didn't state the item. That could have been a frisbee. It could have been a feather. It could have been a dandelion. It could have been a fucking rose. You didn't state it.
Objection.
I just stated it. It was a baseball.
Hang on, Flatten. 1 second, guys. Flatten, go ahead. What's your objection?
He's stating that I didn't state something that I clearly stated.
All right, so now he's bringing a point of clarity. He's talking about a baseball or a cricket ball.
Yeah, I heard that. I did hear the baseball. So, my point was about him before he was doing his thought experiment. I'm trying to say to him, you didn't, because you didn't clarify it before. That was I had a problem with your explanation, because now he's jumping to the ball.
Yeah. So hang on, guys. Hang on. So we're moving forward right now, reasons, and now we're talking about the baseball and the cricket ball. So
all right. We drop a cricket ball. We drop a baseball. Right. So what's your problem with that?
No. You choose one or the other, because it has to be the same.
Cricket ball, baseball doesn't really matter. Baseball. Yeah.
So the baseball is headed towards the more dense medium, even though you have agreed that objects will be slowed down as they go towards a more dense medium. The object accelerates as it's accelerating towards a more dense medium, and your reason for this acceleration, you say, is because of relative density.
Yeah.
So let me make sure I'm not misunderstanding you. Even though you agree, you said so yourself, and I guess you guys record these conversations.
Yeah.
An object will be slowed down as it goes towards a more dense medium.
Mm-hmm.
You're describing an object accelerating as it's headed towards a more dense medium.
Yeah.
And since gravity, as we understand it, is not a factor.
Are you finished yet? Like,
nope.
listen.
I'm almost done. Not finished.
Okay,
and as you describe relative density as being the factor, well, density has now contradicted itself.
No, you haven't. You're just not misunderstanding it. This is one of the main points that you're not listening. The fact
objection.
I ain't finished.
Objection on the table. There's an objection on the table. Flatten, what's your objection?
As he had stated before, an objection of my lack of clarity. I am now stating for him, therefore, he did not provide clarity at that time. So there's my objection. Point of clarity.
I disagree with his objection. Sorry.
Go ahead, reasons. He stated why he's objecting. So
I disagree with his objection because he's already made an assumption of what the answer is going to be without even giving me a chance to rebuttal. The fact that he said that his item is going to drop into a denser medium and should slow down, when he hasn't even heard my answer, he's already made an conclusion.
I don't see where an assumption is made. I
You already
reiterated
got
what you
conclusion.
said. Hold on. I reiterated what you said, and I asked you as I was reiterating. You said this, you said this, you said this. Also, you're saying that there's
Hold on.
more.
Hold
There's
on.
more to your story, and I spoke after you had finished your point, so I did not prevent you from providing that clarity.
You give the answer. You give me your rebuttal, right? And you said that it should slow down through the medium, and you already concluded that I was wrong before I even answered.
No, you said that it should slow down through the medium because that's what you said.
But that's not that wasn't my response to dropping a baseball in the atmosphere in the air. Because listen to the answer, right? You already concluded that it would slow down because of what I said previously. This is a separate situation, and I think that you should think a bit better. You should think about it a bit more because when it goes through the air, the air probably wouldn't slow it down when it gets close to the ground. Yes, it is thicker than it is up in the air, but it's negligible. Would it slow down when it hits the water? Now the waters are definitely a substantial amount of thicker medium, and it obviously wouldn't go through the water like it did for the air. So now you see where you're going. Now where you're wrong. Because a thicker medium needs to be substantial. Don't just say, "Oh, because the air's a bit thicker at the bottom, therefore it fact it should slow down when it gets closer to the floor." Because that's you already concluding an answer before I even responded.
So let me respond to that. You said that an object will slow down as it goes through a thicker medium.
Of course,
you're now saying, "Oh, come on!" You spoke without interruption. So now you're saying that an object has to have a substantially thicker medium. I guess the rate of change of the medium has to increase at a great rate in order for the object to slow down. But that contradicts the laws of motion because if the medium is only slightly more thick as you're moving, then the object should only slightly slow down, not accelerate. So I could accept an argument where you would say, well, the baseball, as is, I guess,
like I said, it needs to be substantial.
But it's dropping at like 2 miles per second, right? Squared, right? It would drop at 1.9, 1.8 maybe by the time it hits the ground instead of accelerating because the object is accelerating and it's accelerating substantially, even though you have just said the medium is only gradually becoming thicker.
Objection.
There's an objection on the table. Okay, so reasons. What's your objection?
He's taking something that I said earlier about how objects will slow down through thicker mediums, and now he's trying to use the baseball example as comparable to air, when obviously air has not much resistance on slowing down something reaching terminal velocity, as compared to a thicker medium such as water would be more accurate to what I was saying. He's basically like taking something that I said in the past and trying to conflate it with something that obviously doesn't factor in this example.
I object to your objection because at the beginning of this discussion, we spoke about throwing a baseball in the air, and I spoke very clearly about it being air only. And you agreed that an object that is going through the air, like a baseball, if it's thrown, it will slow down if it is in a more thicker medium than otherwise. And I even had you clarify it on multiple levels.
1 second, Flatton. The baseball going through the air wasn't brought into till later in this argument.
It was brought in early on, sir.
As I remember it, it was when you said the baseball and the cricket. Remember that's what you stated.
No, prior to that, when we had established the framework of this, hang
on 1 second, Flatton. 1 second. No, it was not stated because Reasons didn't know what you were talking about. That's why he was actually asking the question, for clarity, what is it that you're talking about going through the medium? So can we play
back the tape?
Yeah, well, you don't need to. I've been listening. So
I've been listening and speaking. I said very clearly at the beginning of this,
understand.
If you throw a baseball in the air,
but it wasn't stated. I'm sorry, it wasn't stated, Flatton. So he didn't understand, and that's why the point where I asked you for clarity what it was that you were talking about, then you said either a baseball or a cricket ball. So that's the reason why. So now I'm gonna have to take another objection away. You got one left. So hopefully, please make it where the objections are correct.
Let me make sure I understand the objections here. So I have one objection to his 0.
No, he's got 3.
We had 3 objections starting out.
Yep.
Right. How does he get 3 objections? How does his objections get added on?
No, they don't.
Mine only get taken away.
No, they don't get.
But yet when I make an objection, they only get added on.
Now I'm gonna have to speak. Please don't interrupt me when I speak. I'm the referee right now. So if you answer something and it's not valid, then I could take one away. If it is valid, I let it continue. So the only reason why I would take an objection away is it's something that you are mistaking them on, like in the discussion, the debate. So like I'm clarifying that you did make a mistake, that he was asking for clarity as to what was going through the medium. And you did clarify that. And then you said that you were actually talking about that earlier on, which what didn't happen earlier on because we didn't know what you were talking about until this point came across where you were talking about the baseball and the cricket ball. So now that's the reason why I took this objection away. But previous to that, you weren't getting any taken away. You only get them taken away when you're making an invalid objection.